Today's video is going to be on perfect squares and the difference of perfect squares. So our learning goals for today are, by the end of the lesson, you'll be able to expand perfect squares and you'll also be able to evaluate the difference of perfect squares. So a perfect square is the product of any rational number or expression that's been multiplied by itself. So for example, 9 is what we call a perfect square because it's the product of 3, which is a rational number, multiplied by itself. So 3 squared is 9. So 9 is the product of that rational number, therefore it's a perfect square. So a squared is a perfect square because it's a number multiplied by itself. We could also say 2y squared is a perfect square because it is an expression multiplied by itself. A term multiplied by itself. We've also got x take 1 in brackets and all of that squared. Again, that's an expression and it's been multiplied by itself, so it's a perfect square. Or 3y take 2, another expression, and if we square that whole thing, that's another perfect square. So those are all different examples of perfect squares. That's by no means an exhaustive list, it's just some examples for you to get an idea. Okay, so expanding perfect squares. We've got a perfect square here. We've got a plus b, so we've got our expression and we're squaring it. So that's a perfect square. So to square that, first, I'm just going to show you the full working. So that's the same as doing a plus b in brackets, a plus b. And then we know what to do from here because we've done binomial expansions already. So we're going to apply the a to our brackets, a plus b, and then, plus b to our brackets, a plus b. And then we can expand. So it'll leave us with a squared plus ab plus ba plus b squared, and we've got like terms there, so ab and ba are like terms. Remember, even though the variables are around the opposite way, they're still like terms. So a squared plus ab plus ba will leave us with 2ab plus b squared, and that's as far as we can go. So what we've got here is actually a bit of a pattern for perfect squares. So we've got a squared here, in the middle we've got plus 2ab, and on the end we've got b squared. So as we go through expanding more perfect squares, you'll see this pattern kind of repeats itself over and over again. And the more practice you get with this, the quicker you'll be able to expand these perfect squares, because you can skip some of these first steps here and you'll be able to go straight to this kind of format that we've ended with, because they always follow this pattern. So we've got another one here. We've got a take b squared. This time we're doing subtraction. So again, we know if we write it out properly, that's the same as we're going a take b, a take b. And then it's just a binomial expansion which we can do. A take b, plus a negative is the same as take. So b, a take b, leaving it with a squared, take a b, take b a plus b squared. So that'll leave us with a squared. Now ab take ba is the same as doing take 2ab plus b squared. So again, we've got that same kind of pattern. We've got a squared, take 2ab plus b squared. So it's kind of the same as our first one, except this time because we're doing subtraction, we're subtracting the 2ab part. So just make sure you're getting familiar with this kind of pattern, because we're going to use this when we expand our perfect squares. Okay, so difference of perfect squares is a little bit different. So this time we've got one that's adding and one that's subtracting. So we'll expand our brackets out using our binomial expansion. So we've got a take b, plus b, a take b. So a times a is going to leave us with a squared. A times negative b is going to leave us with negative ab. Plus b times a will leave us with ba. Positive b times negative b is going to leave us with negative b squared. And from there, we can kind of we can collect our like terms, I should say, and simplify our expression. So a squared, so take ab plus ba, they'll kind of cancel each other out because one we're taking, one we're adding, they're going to cancel out. So we're just going to be left with a squared take b squared. So you can kind of follow this pattern again. So for our perfect squares, we know our pattern was a squared plus or minus 2ab plus b squared. And for our difference of perfect squares, we're going to have our first one squared, a squared, taking our second one, b squared. So if we were to look at this for our alternative solution, we could just kind of skip straight to that because we will know the pattern of these difference of perfect squares. So we notice a plus b, a take b. You should go, oh, that's a difference of perfect squares. So we know our answer will be our first number squared, take our second number squared. And you can kind of work your way up to this as you get more familiar with it. Okay, so we've got a few more examples of expanding perfect squares. So I'll start off with A. We've got x take 2 squared. So that's the same as doing x take 2, I should put that in brackets, and then x take 2. So you can see there we've got perfect squares. So we'll apply x to our second bracket, and then our take 2 to our second bracket. So x times x is x squared, x times negative 2 is take 2x, take 2x times x is take 2x, take 2 times take 2, or negative 2 times negative 2 I should say, is positive 4. Collect our like terms, x squared, take 2x is the same as doing take 4x plus 4. Now, if you think back to our first example with our a's and b's, you can kind of see we follow that same pattern. In this circumstance, though, we've got our a, x is our a, and our take 2 is our b. So we've kind of followed that same pattern. And we finished with a squared, which is x squared, take 2ab, which is take 4x, and b squared, which was represented by the take 2, which would be 4. So we've still got that same kind of pattern going on. Okay, our second one, again, we've got another difference of two perfect squares. Difference of perfect squares. 2x plus 3, 2x plus 3. So this is a positive one. So we're following that a squared. We'll have plus 2ab plus b squared. So you could skip straight to the answer, but again, I'll show you how to step it out properly. So 2x plus 3, just doing a normal binomial expansion, plus 3, 2x plus 3. So 2x times 2x will give us with 4x squared. 2x times 3 will give us 6x. 3 times 2x will again give us 6x, and 3 times 3 is 9. Forgot my equal signs. Okay, and again, we can collect like terms. So 4x squared, 6x plus 6x will give us 12x plus 9. And look, we've followed that pattern now again. So our a was our 2x, and our b was our 3. And we can see we followed the pattern. So 2x squared is 4x squared, so that's our a squared. AB would be 2x times 3, which is 6x, and we've multiplied that by 2 to get our 2ab, which is our 12x. And last of all, our b, which was 3, b squared, which is 3 squared, is 9. So we've followed our pattern again. We've got our a squared plus 2ab plus b squared. So we're following that same pattern. Okay, so we're going to do forming a difference of perfect squares. Sorry if I was just a bit jittery there. Actually, I just had to pause it because my phone alarm went off, which is kind of not what we want in the middle of a video. So back to our difference of perfect squares. You can see in our example A, we've got x plus 2 multiplied by x take 2. So that's a difference of perfect squares. So if we think back to our previous slides, we know our answer for a difference of perfect squares should kind of follow that format: a squared take b squared. So I'm going to write the answer here, but then I'll step it out as well. So in this case, our a is x, so x squared is x squared, and our b is 2. So we're going to take our b squared, 2 times 2 is 4. So hopefully that's the answer that we'll get down to, but we'll work it out fully. So for a start, we're just going to work this out like we're doing binomial products. Plus 2, x take 2. So x times x is x squared. X times negative 2 is negative 2x plus 2x, because 2 times x is 2x, and positive 2 take 2 is going to give us 4. Negative 4, sorry. And from there we can collect our like terms. So x squared doesn't have any like terms. Take 2x plus 2x is going to leave us with 0, and then take 4 on the end. Perfect. So we've ended up with x squared take 4, which is what we thought we would. So we've followed that pattern where we're going to have a squared take b squared, just following the pattern through as well. So I'll just clear that. So for our next one, it's the same thing. We've got a difference of perfect squares. We've got a negative and a positive difference of perfect squares. So we know our answer is going to be in that a squared take b squared. So our a is 3x. So 3x squared is going to give us 9x squared. Our b is 2y, because remember it's take. So it's going to give us with 4y squared. So we'll work through properly, see if we get back to that answer if we just followed the pattern. So we'll have 3x applied to our second bracket and take 2y applied to our second bracket as well. So 3x times 3x is going to give us 9x squared. So 3x times 2y will give us 6xy. So then we've got our next lot of brackets. So negative 2y times 3x is going to give us negative 6xy. Negative 2y times positive 2y is going to give us a negative 4y squared. And from there, we're going to collect our like terms. So 9x squared doesn't have any like terms. 6xy take 6xy is going to give us 0. So just take 4y squared on the end. So you can see we've followed that pattern again with our difference of perfect squares. A squared take b squared is going to be our answer there. So that's all we've got for our difference of perfect squares and our perfect squares lesson. If you do have any questions, as usual, make sure you come and see me. Practice these questions from your textbook, use Hot Maths, all those kind of things.